Welcome everyone to the Hobby and Tech Warrior, where we delve deeper into the little secrets hidden within the hobbies that preoccupy us. J4 here, and in this video, I have something airsoft for you, specifically part 3 of the ICS M4 S system rebuild, where I install the inner barrel, focus on the compression components, and reassemble everything together into the initial iteration of our ICS AEG test platform. Working on compression can sometimes be one of the first things to consider in an AEG build. Besides matching parts to an aesthetic goal, the choice of mainspring rating dictates the minimum level of performance required out of the drivetrain and electrical system. Higher stress builds due to higher spring loads will demand more from the system to work correctly without breaking. But because this series focuses on the restoration phase, the level of stress presented by the existing stock parts are relatively low, which allows me to focus on sharing the fundamentals that need to be considered when putting together an AEG. So if you're looking for a different focus of the rebuild process, I will leave a pop-up here. Otherwise, you can follow the links linked in the description down below. And without further delay, let's get to it. Automatic electric guns, or AEGs, work fundamentally different from gas-operated airsoft guns that rely on the expansion of compressed gases to run their mechanisms. Instead, AEGs have a powertrain that runs on electricity and drives a pneumatic pump that transfers air from a cylinder reservoir into the inner barrel. The resulting air transfer has more in common with the physics of fluid dynamics and is what launches BBs from AEGs. Therefore, the reason for coming up with a ratio is an attempt to closely match the air being transferred from one container to the next, where ideally, the BB exits the inner barrel precisely as the face of the piston head contacts the rubber pad on the cylinder head. This would mean that the mainspring will have transferred the optimal amount of stored energy during the air volume transfer. The piston head contacting the cylinder head sooner than the BB can exit the inner barrel slows down the rate of acceleration possible and does not make full use of the mainspring's stored energy. On the opposite spectrum, the BB leaving the inner barrel prior to the piston head contacting the cylinder head results in a sudden loss of back pressure against the piston assembly. Not only does the BB exit the inner barrel without the full transfer of energy from the mainspring, the lack of back pressure causes the piston assembly to slam against the cylinder head with greater force. For builds making use of mainsprings with high spring rates, this can lead to an eventual gearbox shell fracture. Unfortunately, a 1-to-1 ratio is not optimal because environmental conditions are never perfect. Factors such as air leaks from blow-by and drag caused by friction require that some level of overvolume be applied. However, be careful when applying an overvolume, as it could lead to joule creep, where muzzle energy readings rises by merely swapping to heavier weight PBs. If not accounted for, the AEG's muzzle energy readings may surpass game site limits, which may prevent you from playing, or worse, exceed legal limits, no longer classifying the AEG as an airsoft replica. As for my own preferential rule of thumb, I like to target a ratio between 1.4-to-1 and 2-to-1 on 0.2 gram to 0.25 gram BBs, where the air volume carried by the compression components in the gearbox should fall anywhere at or between 1.4 to 2 times the air volume of the inner barrel. This extra air volume, I hope, would be sufficient to compensate for the efficiency losses I briefly mentioned earlier and prolong the gearbox's service life. In the end, deciding on the ratio is one that involves a lot of trial and error and dependent on many factors, the specifics of which I will not be tackling in this video. That being the case, I like to start by picking out an inner barrel setup. If I wanted to maximize the BB's exit velocity, I would need a long and tight inner barrel. If I need the AEG to be physically easier to maneuver around obstacles, I may opt for a relatively short inner barrel to match with a short outer barrel. Well, not much time was spent deciding on this matter, because part of the salvageable components did include a JB Unicorn tight bore inner barrel and deep fire hop-up chamber that was modified to fit. The inner barrel measures 363mm in overall length, which is the figure I ended up with after accounting for the section of branding on the measuring tape I used. It has a stated inner diameter of 6.01mm, which is lightly engraved on the outer surface. With these measurements, I can compute for the air volume capacity of the inner barrel by using the formula for volume of a cylinder, pi r squared multiplied by height, whereas the length measurement of the inner barrel replaces height. Radius is half the inner diameter of 6.01mm, which is 3.005mm. The value for pi, 3.14159, is multiplied by 3.005mm squared, giving me 28.36864mm squared. Multiplying this value by the inner barrel length, 363mm, gives me the volume, which is 10,297.81496mm cubed. However, BBs do take up some space when fully chambered, so I had to compute for and subtract its estimated volume from the inner barrel to come up with the final value I will use to compare against the compression components inside the gearbox. I say estimated because not all 6mm airsoft BBs are actually 6mm in diameter. That being the case, running the formula for a sphere, 4/3 pi r cubed, where r is the radius 3mm, gave me a volume of 113.09724mm cubed, which I subtract from the volume of the inner barrel, giving me a final value of 10,184.71772mm cubed. I now have the air volume capacity for the inner barrel, which I need to compare to the capacity in the main compression system to come up with the ratio. However, to get an idea of any improvements I make, I first tested and computed the air volume capacity of the stock ICS parts by again applying the formula for volume of a cylinder. The initial chronograph readings returned huge discrepancies between single and auto fire, which turned out to be due to a broken cylinder head and portless piston head. The rubber pad had separated and returned unreliable readings. I was still able to compute for the air volume capacity by first finding the length of the distance traveled by the face of the piston head from when the O-ring establishes its air seal up to its resting position against the cylinder head pad. I did this by partially installing the cylinder head with its pad onto half the gearbox shell and then took note of its depth by scribing the relative position of the rubber pad's edge on the spine of the upper gearbox shell. Using the same half of the gearbox shell, I took out the cylinder head and installed the cylinder with the narrow portion of the teardrop shape in the forward-facing position. I then rotated the cylinder to position the port where it meets the spine and placed a second mark to reference the end of the port that is nearest to my previous mark. Measuring the distance between these two marks gave me a value of 39mm. However, I now needed to subtract the distance that the piston head face protrudes past the O-ring center line because it takes up some volume inside the cylinder, which turned out to be a value of 3.8mm, leading to a final length value of 35.2mm. The radius value is half the inner diameter of the cylinder, or half of 23.6mm, which is 11.8mm. Using the formula results in 3.1415 multiplied by the radius 11.8mm squared multiplied by the length 35.2mm equals 15,397.71170mm cubed. This turns out to be 1.49524 times that of the volume value of the JB Unicorn inner barrel, or a ratio of 1.49 to 1, which is well within the range I set. To improve the compression performance, I brought out replacements I bought from Combat Union, a brand I discovered on Instagram. They had these nice looking photos of their ported piston bodies, which is what attracted me to their account. I do have a sort of first impression review of these parts, which can be found on my website. However, a full assessment was never really done until I started the reconstruction of the AEG in these set of videos. The kits I purchased came with an aluminum cylinder head, ported piston head, air seal nozzle, piston body, and bearing spring guide. The piston head and air seal nozzle are the key components for improving the air seal in this build. Compared to the stock ICS portless piston head, the porting on the Combat Union piston head is much like what is found in most other piston heads and eliminates the barrel suck effect on the piston assembly's return stroke. The barrel suck effect disturbs BBs that are still traveling in the barrel during the piston assembly's return stroke that causes significant reduction to the AEG's muzzle velocity during full automatic fire. And thanks to the single O-ring present on the Combat Union air seal nozzle, a minor sealing point against the cylinder head is added where it previously had none. More importantly, it is tapered at the tip, which allowed it to drive deeper into the deep fire chamber compared to the stock nozzle that got caught on chamber material. This might not have been a problem with a stock ICS chamber, but the deep fire chamber stopped the stock nozzle from reaching the packing, which created a massive leak. As for the rest of the components, I will be using pretty much everything except for the cylinder head, which did not fit securely onto the ICS upper gearbox shell. The tabs on the upper shell are smaller and rounded, leaving a lot of empty space for the cylinder head to shift and rotate in. Instead, I had repaired the stock ICS cylinder head and added a sorbothane pad to mitigate shock from the piston assembly slamming against it. Applying the sorbothane pad involved cleaning out the base of the cylinder head, roughing up the surface, and using contact cement to stick things together. This should help prolong the gearbox shelf's life, as the marketing information states that sorbothane is a material that is able to absorb up to 94.7% shock energy. One thing to note is that the pad does deform under pressure and managed to shift the position of the piston assembly about 1.3 mm forward. The variances caused by this shift is a common criticism against the use of sorbothane pads for airsoft application. Putting together the Combat Union piston assembly involves dismantling the head so that it can be installed over the body. On one hand, leaving the thrust bearing out lightens the assembly and promotes durability. Leaving the bearing on helps relieve the mainspring's axial tension and adds additional preload for a slight increase in muzzle velocity readings. I like to apply a drop of non-permanent thread locker on the threads of the locking screw to prevent the head from coming undone after it is screwed down in place. I measured the distance between the O-ring centerline and piston head face to be about 3.4 mm, which takes up slightly less space in the cylinder compared to the stock head. One thing that stood out to me is the attention Combat Union had given to profile the teeth on the tooth rack to accommodate correction for angle of engagement. Correcting for angle of engagement is the process by which the piston body is repositioned at rest in such a way that the tooth face between the sector gear and piston body pickup teeth engage with maximum or close to maximum surface area, thereby improving their service life, especially when heavy loads are applied on these parts. This adjustment usually might cause a problem with the meshing of the teeth between the sector gear and tooth rack, which necessitates the removal of material from a few of the initial teeth. Now, despite the advantages of AOE correction, not all AEG builds require it. In fact, most stock AEGs do not come from the factory with AOE correction. However, the stock ICS piston on this AEG ended up breaking its pickup tooth during the initial tests, which I attribute to increased stress provided by the higher torque motor and higher voltage battery I used, which have become common upgrade components. Just the same, the application of AOE correction remains a relative choice, but highly recommended when worrying about increased stresses applied to the pickup teeth. The presence of the sorbothane pad does improve the angle of engagement between the pickup teeth, but the additional space it occupied in the cylinder also ended up causing the air volume ratio between the cylinder and barrel to drop to a 1.35 to 1 ratio, a value just below my target range. 1.35 is very close to 1.4, but I decided to swap out the stock cylinder to gain more air volume for what I believe is an old deep fire Type 1 cylinder, which had ports that are positioned slightly further back and a slightly tighter radius of 11.75 mm. Using the same method as before, I was able to scribe new marks onto the gearbox shell spine and calculate the new length of travel. 38.10mm, minus the space taken up by the face of the piston head, 3.40mm, plus the additional space provided by a compressed sorbethane pad, 1.3mm, results in 36mm. 3.14159 multiplied by the radius 11.75mm squared multiplied by the distance the piston travels, 36mm, equals 15,614.48770 cubed, a ratio of 1.53 to 1. With the air volume secured, I took this opportunity to swap out the deep fire chamber entirely for something that was designed specifically for the ICS M4 platform. I bought a Max Model Company CNC aluminum rotary style hop-up called the IE Pro. It comes with an assortment of hop-up arms and circuitry for LED lights to charge glow-in-the-dark BBs from within the chamber. But one other feature I really appreciated was the implementation of a spring-loaded latch that makes up half the rear of the bottom BB feed tube lips. This acts like a claw that closes to hold on to leftover BBs, which would otherwise be discarded during a magazine change. This prevents them from falling out unexpectedly and helps reduce wastage and eliminates sound cues of BBs dropping to the ground that might give away your position. The arm that puts pressure on the packing is a two-part piece composed of a lever and block. Instead of a nub, the bottom of the block is a contoured surface that matches the curvature of the packing and rides notches that ensures a more even application of force along a wider surface. In the case of inner barrels with smaller hop windows, the arm can be swapped out for a more traditional one-piece arm and nub combo. To proceed with the chamber's installation, I prepped the inner barrel by slipping the packing over the end where the hop-up window is located, making sure the ridge and mound are oriented to fit into the groove and window of the barrel. Then, making sure that the chamber is free from obstructions, I push the inner barrel packing first until it stops flush against the inner chamber. At the same time, I make sure that the chamber is oriented correctly by ensuring the ridge on the packing is oriented at the bottom and the mound in the 12 o'clock position up against the hop arm. I then take the included plastic locking clip and install it in the space provided below the chamber's front barrel. The clip grabs onto grooves cut on the inner barrel, which lock it into place. I then slip the brass spacer for frontal stability and then follow up with the provided O-ring to keep it from sliding out. This completes the barrel and chamber setup. Certain aspects of the installation process can be made easier by first dismantling the arm, thereby giving the barrel and packing more space to work with. In my case, the barrel and packing managed to seat without disassembly by rotating the dial to the lowest setting and moving the block out of the way. Before I move on to the mainsprings installation, I need to make sure that the air seal between these parts are in proper order. A good seal traps a cushion of air when the piston is pushed through the cylinder and prevents it from advancing. Any leaks will cause it to go all the way in. The two main locations to inspect are between the piston head and cylinder head's O-ring contact against the cylinder walls. To validate the seal between the piston head and cylinder, I just need to push the piston through while securely covering one end, preferably the front, with the palm of my hand. The O-ring on the piston head should expand against the cylinder walls while trapping in a cushion of air that pushes back against the piston assembly. If the O-ring does not seal well, air will slowly leak and the piston assembly will reach my palm. In case of a leak, swap out the O-ring or stretch it over the outside of the cylinder and apply a tiny amount of heat to it in an attempt to permanently enlarge it. Checking the seal between the cylinder head and cylinder is done in a similar fashion, only this time the cylinder head is installed onto the cylinder. Again, push the piston into the cylinder while blocking the air from escaping through the head spout by securely covering it with a pointer finger. If the cylinder head does leak air, the piston assembly will reach the cylinder head. If there is a leak here, the cylinder might not be held on straight. Otherwise, inspect the O-ring for damage. swap out the O-ring on the cylinder head for one that seals better, or swap the head out completely. The seal between the air seal nozzle and the cylinder head spout is less of a concern. The space between these parts presents great resistance compared to the path down the barrel. In most cases, concerns here can be solved with light greasing. Otherwise, air seal nozzles with O-rings are available for purchase. The third location to keep an eye on involves the contact between the air seal nozzle's tip and hop-up packing lips. A gap between the air seal nozzle and hop-up packing poses a major air leak. I like to check that the tip of the air seal nozzle contacts the lips of the packing adequately by dropping the air seal nozzle into the chamber while the packing and barrel are installed. I can verify that the air seal nozzle reaches the packing by pressing it into the chamber and paying attention to the presence of resistance or feedback. The air seal nozzle should bounce back against the hop packing. If the air seal nozzle bottoms out without feedback from the packing, a leak is almost always guaranteed. In cases where the air seal nozzle gives off a hard, unresponsive feedback, it is possible that the nozzle is caught on chamber material, preventing it from reaching the packing. In case of a leak, swap out the air seal nozzle for one with a proper length or a different tip profile. Lastly, inspect that the tappet plate moves freely in the gearbox to allow the air seal nozzle to position and feed BBs properly. Drag on the tappet plate can introduce feeding issues and air leaks in higher speed setups. Simply place the tappet plate in an empty upper gearbox shell on its own, and then rock and tip the shell from side to side. And if it gets stuck, it means that either the tappet plate or gearbox needs to be polished or altered to smoothen out the movement. Tappet plate springs with higher tensions are also available for purchase. After the seals have been inspected, I can then reassemble the parts onto the upper gearbox shell and apply a thin layer of silicone oil to the O-rings and lightly grease the outer surface of the cylinder head spout. I can then grease up the guide rails on both the piston and gearbox shell before driving the piston assembly into the cylinder assembly in preparation for the installation of the mainspring and spring guide rod. The Airsoft mainspring is a primary source of power that transfers its stored energy as a driving force to launch BBs out the inner barrel. Securing it into position is the spring guide rod, a part that is inserted into the rear end of the mainspring that keeps it straight. To install the mainspring, insert it into the rear of the piston assembly head first, starting with the end that has widely spaced coils. I then follow up by installing the Combat Union version 2 spring guide onto the end of the mainspring with the tighter coils. I then take the other top half of the gearbox shell and get it into a ready position, so that it can be maneuvered and installed quickly when the spring and guide rod are placed under tension. With my right hand, I thread my fingers through the cylinder window on the top half of the gearbox shell to rest upon and secure the cylinder assembly to the bottom gearbox shell. While trying my best to keep the parts securely in place, I use a screwdriver on my left hand to insert and push the guide rod and mainspring into the gearbox. If capable, I can also try to push the mainspring and spring guide rod into place by hand. Due to the energy stored in the mainspring, securing it to the gearbox can be dangerous if not handled properly, so I highly suggest that special precaution is taken when undergoing this step. The use of protective eyewear is recommended, or consider asking another individual for assistance if the mainspring is too difficult to manage on your own. One technique I use for certain gearboxes that have notches at the rear involved using a properly sized screw and 2 nuts to hold the guide rod in place. If you manage to locate the spring guide rod into place, the first nut can act as a clamp against the lower gearbox shell, while the second nut keeps the first in place. Even with the guide rod held in place, take caution when working with the mainspring and other parts that are under great tension, which may come undone at the slightest mishap. When ready, I take the other half of the gearbox shell and install it over the lower gearbox while securing the cylinder head first. Once the peg on the other half of the shell finds the hole on the cylinder head, I can lower the rest of the shell and push the spring guide rod in to secure it all. During this process, I make sure that the piston assembly remains seated on the rails and the guide rod pegs are slot into place properly. Otherwise, the gearbox shell halves may not close. After securing the gearbox shell with screw fasteners, it is now ready to be installed in the upper receiver for testing. The AEG needs to be reassembled to initiate the tests. However, it was during this phase when I started running into problems. Installation of the inner barrel and chamber assembly had to come first but seemed to jam due to the thickness of the wires in the front wired setup. I removed the LED module and replaced it with the included acrylic panels to free up some space, but that didn't help. It turns out that the bottom base of the max chamber interferes with the lower receiver and prevents the top from closing. Upon checking, Max no longer offers the IE Pro, and the new chamber designs have the profiles of their base updated to clear the lower receiver. I could take a Dremel to my IE Pro to replicate this change, but in the interest of immediacy, I decided to reuse the deep fire chamber to get the chrono readings of the compression parts. Only this time, I swapped out the stock ICS nozzle for the Combat Union nozzle to avoid the air leak problem it had before, or so I thought. With a freshly balanced LiPo battery and a magazine of 0.2 gram BBs, I started to encounter very low muzzle velocity readings on the chronograph. It was reading constantly below 200 FPS, which I found was due to two factors. First, the taper on the tip of the Combat Union nozzle was too aggressive and did not seal against the lips of the hop packing very well. Second, the stock ICS cylinder head I repaired tends to flex a lot and had a leak somewhere I could not find. It did not hold compression when the mainspring's load was introduced. In fact, even though it did not separate immediately, my experiment of using contact cement to stick the sorbo onto the plastic head failed and it came off when I pulled on it. I recommend sticking to the usual CA or cyanoacrylate glue for the adhesives. Because of this, I fell back on a more rigid Lonex B2 metal cylinder head that I had pre-applied sorbo pads to in the past. So far, the contact cement I applied here is holding up, but I will have to observe how long this one lasts. In effect, the combination of using a less aggressive tapered nozzle and a more rigid cylinder head seemed to do the work, and I started to get readings closer to what I was expecting from an old factory stock spring. The readings are now 80 FPS higher than they were prior to the changes made in this video. Resolving the seal between the air seal nozzle and hop packing was a major contribution to this improvement, and apparently despite my best efforts to fix the stock plastic cylinder head, it seems it is prone to leaking, and I highly suggest that this part is replaced for something more rigid. Next, the two thrust bearings in the piston assembly and spring guide places an additional preload on the mainspring that gives us a slight bump in muzzle velocity. The rate of fire was measured to be around 23 BBs per second, which did not exceed the 27 to 30 BBs threshold that requires lightening of the mass of the piston assembly to prevent piston pre-engagement. In those cases, it is recommended to keep the thrust bearing and the piston assembly off. Finally, the boarding on the piston dramatically reduced the muzzle velocity variance between semi-auto and full auto firing modes. So check stock AEGs for piston heads that lack ports and swap them out in cases where there are large dips in velocity readings between firing modes. Due to the sorbo's elastic nature, there was a minor case of joule creep that resulted in about a 7 to 10 FPS variance. However, it was interesting to note that the change was gradual, and the difference of the readings between shots were minimal and relatively consistent. And with that, I have pretty much restored this AEG to working condition. I've maximized the energy the stock mainspring provides by ensuring that the seals are performing as they should, which similarly improved consistency. Even though several of the work I did ended up having to be revised in the end, rest assured that the preparation of these parts that replace them remains largely unchanged, albeit the small details like the type of glue to use. There are still loose ends to take care of, like properly incorporating the Max IE Pro chamber or migrating to a rear wired setup that I find to be acceptable. However, what is important is that I now have a working platform that is easy to service and makes it simple to implement those changes when it is finally time to do so. Overall, I am satisfied with the way it turned out and excited to see which direction this platform will take. That's it for this video. For more information, check out the links in the description below. I hope you found this series helpful. If you did, please leave a like and consider subbing. Thanks so much for watching, and I will see you in the next one. Bye.